What is symmetry? Symmetry means that one shape becomes exactly like another when you move it in some way, turn, flip, or slide. For two objects to be symmetrical, they must be the same size and shape, with one object having a different orientation from the first. There can also be symmetry in one object, such as a face. If you draw a line of symmetry down the center of your face, you can see that the left side is a mirror image of the right side. Not all objects have symmetry. If an object is not symmetrical, it is called asymmetric. Line of symmetry. A figure can have line of symmetry if a line drawn divides it in two equal halves. The line is called the line of symmetry. We find such symmetrical objects in nature. For example, in these ancient buildings. A kite shape has only one line of symmetry. A rectangle has two lines of symmetry. An equilateral triangle has three lines of symmetry. A circle has an infinite number of lines of symmetry. A shape may have just one or more than one lines of symmetry. Point of symmetry. If the symmetry of a shape is around a point, then that object is said to have point of symmetry. If a shape like the circle shown on the screen has a point symmetry, then any point on the shape has a matching point, which is exactly at the same distance from the point of symmetry, but in the opposite direction. Let us observe the figure on the screen with the two yellow dots as shown in figure 1. First, let us rotate it 90 degrees and we get the figure as shown in figure 2. When the same shape is rotated 180 degrees, it looks the same, or it looks same when turned upside down. This figure has point of symmetry as shown in figure 3. English alphabets exhibiting point symmetry are shown on the screen. Some geometrical figures with point of symmetry are shown on the screen. What are the conditions that a shape or a figure satisfies for point symmetry? The conditions that a shape or a figure satisfies for point symmetry, that is, 1. Every part should have a matching part. 2. The distance should be equal from the central point, but should be in the opposite direction. Reflection symmetry. Sometimes called the line symmetry or mirror symmetry, reflection symmetry is when an object is reflected across a line, like looking in a mirror. The face mentioned before is an example of reflection symmetry. Reflection symmetry can be explained clearly with graphical representation also. Observe the graph sheet shown on screen. If ABC is a triangle, then A', B', C' is the reflected triangle. The line of reflection acts like a mirror. Reflection in y-axis. Let us now visualize the simplest reflection of symmetry about a point P, 2, 3 in y-axis. Here we can see that the y-axis acts like a mirror line and reflects the point P, 2, 3 to a mirror image P' minus 2, 3 as shown on the screen. Let us see a reflection in x-axis. In the graphical representation shown on the screen, the point A, 4, 3 has its mirror image at A', 4, minus 3 reflected in x-axis. Here, we can see that the x-axis acts just like a mirror. If A is the image, then A' is the mirror image and x-axis is the mirror. Example: find the coordinates of the point reflected on both x-axis and y-axis in the given graph shown on the screen. Solution: let us consider the graph with point 5, 2 as shown on the screen. 1. The point 5, 2 reflected in x-axis will be 5, -2. 2. The image of the point 5, 2 reflected in y-axis will be -5, 2. Rotational symmetry. Any object or shape is said to have rotational symmetry if it looks exactly the same at least once during a complete rotation through 360 degrees. During the rotation, the object rotates around a fixed point. Its shape and size do not change. This fixed point is called the center of rotation. Rotation may be clockwise or anti-clockwise. A full turn refers to a rotation of 360 degrees. A half turn refers to a rotation of 180 degrees. A quarter turn refers to a rotation of 90 degrees. The angle at which a shape or an object looks exactly the same during rotation is called the angle of rotation. For this figure, when we rotate it to 90 degrees, it looks the same. You can see for every 90-degree rotation, the shape looks the same. When we rotate this figure 4 times, and every time the figure looked same, this means the order of rotational symmetry is 4. The order of rotational symmetry can be defined as the number of times that a shape appears exactly the same during a full 360-degree rotation. For this figure, the order is 4. This is a triangle. When we rotate a triangle in 90 degrees, we get the same shape. Similarly, when we rotate it twice and thrice, each time the shape of the triangle remains same. The triangle gets back to its original position in 3 rotations. When rotated 270 degrees, the triangle reaches its original position. Therefore, the order of symmetry of the triangle is 3. These are some of the figures which have rotational symmetry of order 3. These are some of the figures which have rotational symmetry of order 5. Line symmetry and rotational symmetry. There are many shapes and objects which have both reflection symmetry and rotational symmetry. A regular polygon of n sides has n lines of symmetry and also rotational symmetry of order n. There are some shapes which have only line of symmetry, whereas there are some shapes which have only rotational symmetry. Some English alphabets have interesting symmetrical structures. Observe the pictures shown on the screen. The alphabet A has only one vertical line of symmetry. Alphabet D has one horizontal line of symmetry. Alphabet H has both horizontal and vertical lines of symmetry. Alphabet G has no line of symmetry. E, C, J, no rotational symmetry. I, O, both line of symmetry and rotational symmetry.